practice. This is what we need to learn. Then we'll do, right in the middle of each section, we do a little bit of quiz just to see that we are following, just to keep it more interactive and fun. Because my voice might sound a little bit boring, but I want a situation whereby we all have fun, and then to make sure we understand what we are doing. And yes, we conclude then a little bit of Q&A if there are questions, then demo. Then the most important part of this training is there's going to be a final quiz after the training, and the pass mark for this quiz is 70%. The learning level is going to be, they're going to be sharing the link with us immediately after the training, provided we finish before 2. After 2, then they will have to send it to our emails, but you need to write the exam, the quiz immediately after the exam. The questions are not many, they're just multi-choice questions. Just choose the correct answers, and then, but please make sure you get a pass mark. Over the pass mark is better, 70%. If you don't meet the pass mark, you'll probably have to go through the training again, which obviously might take some of your time. But so please, let's just pay attention. Let's take notes if we can. And then, yeah, Godspeed. Now we begin. Okay, introduction. What is secure coding and why is it important? So from the text you can see above, it says security vulnerability exploits. Show us just how vulnerable software code really can be. Software code sits at the heart of your application works. We know this is the heart of the application. It's the coding, that is the brain of the code, the application rather. If the coding is wrong, then there's a possibility your application is susceptible to attacks. If you can see the text there, it says, if your code has security vulnerabilities, your entire app might be vulnerable to cyber attacks. And this is genuine because you see a lot of big organizations today, they get attacked. We can't say they don't have the money to hire best developers. They have one of the best, or let me say best, the team of best developers in the world, and they still get attacked. Why? Vulnerable codes. So if you look at it, let's just look at a quick glance at the tech headlines over the years, that reviews often security vulnerabilities in software that are exploited by unauthorized users. If you look at the big tech companies nowadays, you talk about Google, talk about Apple, talk about Facebook, and we even look at Yahoo. If you look at the headlines you're seeing here, it says 533 million Facebook users. Facebook users' phone numbers and personal data have been leaked online. Imagine 555 million. And Yahoo had all 3 billion Yahoo accounts were affected. You all remember the attack in 2013, all 3 billion users were affected. If you look at it, you're never wondering, how did this happen? How did this happen? See, even Red Hat, you've heard of Red Hat, you've heard of IBM subsidiaries, you understand, that provides open source software, reported a vulnerability in their Linux enterprise. This happened a couple of years ago. They reported all these sort of things happening. You see, preventing cybersecurity incidents, which can cause leaks or sensitive data and other personal data, starts at the very beginning of the software development process. The very beginning of the software development process. Now, how is the source code itself? How protected is your source code itself? How protected is the source code itself? You need to ask yourself that question. So now, what is secure coding? First, I'm going to tell you what coding is, just like you can see on your screen. Coding, or computer programming, like you say, is a practice of designing executable programs, which is software or applications in a language that can be interpreted by your computer. It's as simple as that. In a language that can be interpreted by your computer, meaning you basically have the brain of the computer in your hands. So you can program a computer, you can program an application. So that code that you do, that programming language, is the brain, is the one sitting everywhere. It's the master, is the brain, is everything. So now, when developers write code, they need to consider many things. What are the things you need to consider when you're writing your code? Number one, the architecture and the design requirements of the application. How much do you consider this when you're writing the code? It is very key. You consider stuff like this, the architecture and design. Number two, the code optimization and efficiency. When you're writing or rewriting code, so that the program can use at least possible memory or disk space. So minimize its CPU time or network bandwidth, or makes the best use of additional cores. So optimization is key. And the third one is the code security and safety, meaning coding with security best practice in mind. That's all it takes. As long as you code with the security best practice in mind, I'm sure you have less attacks. You actually have a sound sleep, even after deploying your applications. You have a sound sleep. All right, let's move on quickly. Now, secure coding, just as it says, very simple, just like writing a software or writing software in a way that guards against vulnerabilities and reduces the risk of exploitation. Simple. It's as straightforward as that. Just simple. So, but let me even ask you a question, like, why do you think secure code matters? That's the first thing a lot of people think. Secure code, why does it matter? See, secure code it makes it easier for you as developers, because I know there are many developers in this training, to weed out common vulnerabilities in your applications by following the best practice and guidelines known as the secure coding standards, which we'll be talking about very soon in this meeting. So, like I mentioned earlier, why do you think it's so? So first, our codes have to be secure. You see, secure coding is essential to ensure that the code is what? Secure. Number one, it has to be secure. Number two, your code has to be what? Reliable. It has to be reliable. And finally, it has to be what? Free from vulnerabilities. It has to be free from vulnerabilities. The last time I was speaking with the developers from the BST, I was asking the kind of language they write it in, and they were telling me C#. You see, C# is a possible programming language that requires developers to follow secure coding standards. If you're going to prevent any security risk, it's best to follow, most especially when it comes to C#. It is very, 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 very important that you do it. See, secure coding actually is very important because one, it ensures the confidentiality. We are aware of the CIA triad, right? It ensures the confidentiality, the integrity, and the availability of software and data. That is the key. And it also protects against vulnerabilities. Any sort of vulnerabilities like I've mentioned earlier, or exploits or attacks, it protects against them. And most importantly, it minimizes the risk of data breaches and unauthorized access. If your code is properly coded, is secure, is reliable, with no vulnerabilities, you realize that it reduces the risk of data breaches and even unauthorized access. If you're not authorized to code that shows your code. If your code is basically vetting every input that is being entered into an application, you're vetting it, you're validating every input, definitely it will prevent unauthorized access. And you find it will definitely preserve user trust and reputation. Okay, so do we have any questions from what I've said so far? Any questions from what I've said so far? Because I'm about to give us a very quick quiz from what I've just said. So, because I want us to be interactive, to be sure that we are taking notes and we are listening. Okay. So, just like I said, why does it matter? It ensures the confidentiality, the integrity, and availability. This is the CIA triad of software and data. It protects against vulnerabilities, exploits, and attacks. It minimizes the risk of data breaches and unauthorized access. It preserves user trust and reputation. This is key. Now, like I said, I'm going to give us quiz even as we go on. So this is a quick quiz, and I want everybody to drop their answers in the chat. And the quiz says, which best describes the meaning of secure coding? A, writing code without bugs. B, writing code with strong encryption. C, writing code with security best practices in mind. D, writing code that is resistant to attacks. Let's go. So I want to see your answers in the chat box, please. So you either put maybe A, B, C, or D. Okay, I can see some people are putting C. Right. Okay. So everyone is saying C, I believe. Okay. Yeah, that's correct. So that is the answer. C is the correct answer. Just like I said earlier, it is writing it with best practice in mind, with the standard, secure coding standards. All right. Now we'll move on to the next slide. So, cyber resilient application. Approach to building a cyber resilient application. So, we'll look at it this way. So, building a cyber resilient application requires an essential comprehension of security standards, right? Just like we said earlier, proper security should ensure the confidentiality, the integrity, and the availability of information within a business. Okay? So if you look at it, said this should all happen with the end goal of what? Empowering business operations, but do not so requires an understanding of the risk associated with doing business digitally. So to achieve all-round security, these practices must be embedded in the software development lifecycle. Right. In the original software development lifecycle, if you look at the image on your screen, we have it with testing, right? But we didn't have testing in all the stages compared to the secure software development lifecycle. And I believe this is the ship left you are using right now. Because I know our software developers now, when they are doing their planning, obviously, you need to do gap analysis. So that is your testing. You know, in the stage of the secure design and prototyping, you do threat modeling. Okay, what are the things that possible attacks, what could go wrong, and this and that. Then your main coding part, you start doing your secure coding. In the secure development, obviously you start testing and all that stuff, using the SAST and all that. In security vulnerabilities, you do unit testing. You scan, use the SAST. Secure deployment, build what? Routine security testing. We test, okay, so like for what we do before an application is deployed, we run a test first. Even when the application is deployed, we still run a test just in case something has changed. I think the BSD team can attest to this. Mr. Sam and I, we do engage on things like this. You know, when we run a test, we do the test again just to be sure that this vulnerability does not exist. And if we by any chance find a vulnerability, we send it back to them to let them know that until this is fixed, this cannot go on. Why? Because we're trying to protect our space to be sure that attackers don't get any sniff, you know, at our environment. Because once they come in, they just spread like ants. So we don't want that to happen. So while you're obviously maintaining and monitoring, you do a bug bounty program. See, you see bounty hunters and all that stuff. You start looking at the perimeter to be sure that they are not selling credentials or no credentials are leaking or anything on the dark web or what have you. So you basically monitor, and we have devices we use to monitor applications. We have the WAF, we have the DAM, all sort of things just to make sure that our space is protected. Okay. Now, so before I get to this, so I'm just going to do, okay, well, we are still coming here to some high steps that we can follow. So before that, I just want us to understand that like the need for rapid digitization, this word always gets to me, digitization. Yes, digitalization rather, yeah. You know, is to make our work eager, malicious hackers are launching various new forms of cyber attacks. Whether you like it or not, they keep launching new attacks, meaning we have to get ourselves informed. We have to get ourselves, we have to read up, we have to train ourselves on these new attacks. We can't just sit down and say, okay, when it happens, I'll hack, right? They say the best form of defense is an attack. So you at least start thinking like the attacker. What do they do? How can they attack this system? What are the things you understand that could be vulnerable about this application? So you see, that's what leads you to knowing that building a highly cyber resilient application involves implementing strategies, the strategies that can help the application withstand cyber attacks and then would allow you to quickly recover from incidents caused by them. That's the kind of mindset we need to have, the kind of mindset. You see, you know that definitely to achieve all, and just like what we've said, you see, these best practices that we are going to be mentioning now, number one is obviously conduct risk, you know, must be embedded in all the stages of our security software development lifecycle. All the stages of our security lifecycle. Okay, so we're going to start. Number one definitely is what? Conduct a risk assessment. I know I don't need to ask the software development team this, but I believe it's one of the things they do. They conduct risk assessment. You know, the risk assessment obviously would help you identify, I don't know, maybe possible threats. It will help you identify possible threats and vulnerabilities in your applications. Obviously, they will also help you prioritize critical risk. And then they will help you strategize for mitigation. This is where you start developing strategy to mitigate them. Any sort of risk you understand, you start developing a strategy to mitigate them. And obviously, these are the standards that can be leveraged based on the organization. So if the organization or the team does not, conduct risk, obviously, you're shooting yourself in the leg. Okay. Number 2, practice threat modeling. So threat modeling process is just the process of predicting potential threats and vulnerabilities. How do you with the kind of application, the kind of application you built, right? From the first, you've already conducted the risk. Now, okay, fine. So what exactly do I think this application can be a threat to? What kind of threats available for an application like this? How do I predict that? So this is what you're doing in threat modeling. Okay. Obviously, it also focuses on how the mind of an attacker works. You said, think like a thief. That's how you can catch a thief. How do they think? Think like the attackers do. Like in security, what we do is we set up our own lab. We spin up a lab. We try to we create a vulnerable application somewhere and start thinking like the attackers would do. While you're attacking a vulnerable application, you're strengthening it, right? You see the vulnerability, we fix the vulnerability, and we try to attack it again and see other ways by which the attacker can still attack. So we have a threat team in the security department. You understand? They do this a lot. They kind of look for the areas, you understand, that we need to strengthen in the bank, with the aspect of security. So these are the kind of things we focus our mind. We focus on the mind of an attacker, how the attacker works. All right. So that's one of the things we need to do. That obviously when you do that, when you focus on how an attacker work, this would be an advantage. Obviously, if you don't learn how the attacker works, they could take an advantage on the vulnerability to exploit the systems, and they will obviously take sensitive data. Okay, just to clear that out. All right. Number 3, implement a defense in-depth strategy. What does it mean? Obviously, it involves implementing various layers of security controls. You can see from the diagram here, there are different layers of security controls. Obviously, you have the critical assets right in the core. And over you have the data security, application security, whereby you have WAF, vulnerability scanning, application whitelisting, what have you. And you have the human element. This one is actually key. The human element. What awareness do we create? We know the communication and development was the department. They do send us a lot of cybersecurity awareness. We need to train ourselves about the attacks, most especially our departments. And this is what we are doing today. One of the things we are doing today, to train ourselves, create awareness. Because we can't say that we have this sort of lackluster mindset as to what is going on in the world today. We need to train ourselves. It is actually very key we train ourselves. Also, one of the things we need to look about is how do we put security controls in place? Such as zero trust architecture, the least privilege principle, which I've listed. We need to put the WAF in place. The WAF is actually key. Microservices, I know quite a lot of us from the TSD. I think when we have external vendors, they share their microservices with us, or we connect to their microservices or through their APIs. These are the kind of things we need to put in place. And then be careful. Even when they send us applications, one of the things we need to be careful of is not to use their default password, default credentials, because you don't know the kind of backdoor that has been set on the system, right? Okay, one of the things, WAF, yes, and anti-DDoS. Obviously, we have more than that. We have the runtime application self-protection, which is the RASP, and many other intrusion detection, IDS, and other access controls that we could put in place. If you look at the diagram, everything is all listed in there. So this strategy obviously will help prevent attackers from exploiting vulnerabilities in your application. It's as simple as that. Once you have all this in-depth strategy in place, defense in-depth strategy in place, you know that at least you can sleep well at night. And firewall, basically. All right, the next one is to implement security by design. Implement is security by design. This is what we've been saying since. It's just like secure coding. The same thing, secure development lifecycle, just like I showed, just implement secure it at every stage of your software development lifecycle, at every stage. So when you implement security by, it involves considering security requirements throughout the development lifecycle, right? This approach obviously ensures security is built into the application from the beginning. It's built in from the beginning. This is not an afterthought. It's from the beginning. The security is built into the application from the beginning. Obviously, you think about the security testing should be what implemented at various stages of the SDL. So obviously, the OWASP you are looking at, we'll be talking about this shortly. And the OWASP testing framework. This is what we should use. I'm going to share a document of this OWASP testing framework with the team after the training, mainly for BSD. Actually is more paramount to BSD to have it. I don't know if they already have it, but this is the OWASP testing framework. Shows you exactly the things to look out for, even when you're developing your applications or writing your code. This is not just for the security team alone. It also kind of like keeps you prepared. What we do is to test your code to make sure that your code is right, your application is not susceptible to attacks and all that. But it will do you a lot of good to understand how these things work, so that you build your code, in preparation for the testing. Even makes the job easier, so that we don't start returning and say, okay, guys, why is this like this? Why is this like this? So that's why I always want that synergy, so that we can work together and make sure that we deploy on time. Okay, so next one is use secure coding practices. This one is very key. When we write secure coding using industry best practices, such as, we talk about input validation. We are going to be looking more into all these best practices. We talk about, output encoding, error handling and proper session management. Just make sure secure coding standards and framework, such as OWASP. The OWASP Top 10, SANS 25, and Carnegie Mellon Software Engineering Institute. I don't know if any of you have actually heard of this, but it's actually one of the standards being used. And number 6, conduct regular security testing. Don't ever stop testing. Don't ever stop testing. Even if we send it back to you and tell you that there are no vulnerabilities, check your code again. Check it again, keep checking, because it's your reputation on the line. If you write a code, I'm talking to developers mostly now, you develop an application and then we keep telling you, or customers keep saying, no, sorry, this keeps happening. That means you're not taking time to, check, because I don't rest, because I keep checking. I'm like, okay, so what else can go wrong? You start thinking outside the box rather. Then you read and read, do more research. Read more, look at the trend, look at the security trends, look at the kind of attacks that are being developed, because attackers don't sleep. When we are sleeping at night, feeling that we are okay, we are in a comfort zone, they are busy writing different codes, writing different attacks. They are developing malwares, developing antivirus, developing viruses. They're developing more things. The moment a new technology comes up, trust me, there's already an attack for it. There's already an attack for it. You'll now be wondering, how did these guys know? Trust me, they do know. They do know. And funny enough, you'll be surprised that most of these developers, some of them are even the attackers themselves. You get? So these are the kind of things we need to keep testing. Don't ever stop testing. So conducting regular security tests, to identify vulnerabilities and weaknesses in application is very, very crucial. Very, very crucial. Do a lot of pen testing. Security code reviews, obviously the applications for this, which obviously we'll talk about in the later stage of the training. And also you want to do vulnerability assessment. This is very, very key. Now, so this high-level steps that I've just given you was actually taken from an article by the CISO, Mr. Zachariah Akinpelu. The topic of the application is a practical approach to building a cyber resilient application. Okay, the CISO is a member of the Forbes Council member. So if you can check the link, you can access it. I can share the link later on the chat. Let me even see if I have it. Yeah, I can share that on the chat so that we can go through it and read and learn more from it. Okay. So, any questions before we do our next quick quiz? And I hope we are taking down notes. Any questions? Okay, no questions. All right, so now, quick quiz.
Sorry, Larry.
Okay, yes,
Yeah, my
go
name is
ahead,
Larry,
please.
Actually. Your name,
Yes,
sir.
please.
Sorry. My hand has been raised up.
Oh, I'm so sorry.
No, I
I have
understand.
my full screen. I can't see it. Yeah, sorry about that.
Sorry.
Yeah.
I think you mentioned this almost at the tail end. It was a concern for me.
Mhm,
Having looked at the software development lifecycle and the security by design.
mhm,
Something just came swiftly to my mind, because security is like a quality aspect of every system. And once your system is just
mhm,
insecure, apparently the quality is low, you know. So after
mhm,
you gave those examples, so something else came to my mind that after the implementing of the security by design, should this be like a one-off thing or a one-stop shop, or should this be like a regular exercise and it continues that way? Because there are often flaws, failures, and an exception. And of course,
mhm,
in the first 5 stages of the SDLC, you have at the inception, the designing, the implementation,
mhm,
the maintenance, and of course,
mhm,
your audit comes also, and then towards the
mhm,
tail end, either your disposal and basically the assessment of the risks
mhm,
of the management plan.
mhm. Okay, so basically, it doesn't stop. It doesn't stop. It's a regular thing. You don't stop. You don't stop when you just test and then you pass it. So, like I mentioned earlier, what we do is that in the application security is even after you've passed an application, you still run regular tests. Case and point, I think the unifier, I'm going to use the unifier as an example. After the unifier 1.0 was passed, obviously, because of the constant periodic test we run, because you should have like a strategy, for your unit. How do you ensure that this application is secure, that nothing actually goes on? Because the fact that at that point there was no vulnerability does not mean the attackers have not developed new ways of attacking it. So that's why we need to keep testing. So I think Mr. Sam can bear me witness to this. There are many times I've actually reached out to him personally of something we've discovered, like an attack trying to come to an application, or when we find some sort of issues with APIs on authentication of a particular endpoint. We reach out to them to let them know that, from our test, we realize that this aspect is vulnerable. Can we try and fix this as soon as possible? Right? So, and this comes from the regular test. We don't just test it and say, okay, fine, it's done. We go and sit down. No, we do it often, periodically, actually. So, and that's how it works. So from there, then definitely, we know that we are having a cyber resilient application. So it doesn't stop. So it's a continuous process. Does that answer your question?
Yeah, absolutely. Great.
Okay.
Thanks.
All right. Thank you very much. Okay. So quiz. SDLC stands for A, software DevOps lifecycle. Fantastic. B, server development lifecycle. C, software development lifecycle. D, secure development lifecycle. So please, if it's A, B, C, or D, please let me see you type it. I know I gave away expo because I left it on the screen for some time. So, but obviously I know we are brilliant. So yeah, let's go. Okay, please. I want answers. I want responses. Everyone, I can see people saying there's C, software development lifecycle. Are we all in agreement with that? Okay, so I guess that's perfect. So we are all in agreement. Okay, so we begin. Yeah, correct. The answer is C. The answer is C. The answer is C. Thank you very much. Sorry, my network just froze. Okay. Okay, now we move on. Quiz number 2. Which of the following is not, you can see the emphasis there, not part of the discussed high-level steps to building a cyber resilient application? I just mentioned all the high-level steps. I think about 6 or 7 of them. 6 of them have been about, yeah. So which of the following is not? A, conduct regular security testing. B, implement reverse engineering. C, use secure coding practices. Please, I need you to listen to the question. They said, which is not? Then D, conduct risk assessment. Okay, let's see.
I think it's B.
Yeah, you can just drop your things on the chat. A, conduct security testing. B, implement reverse engineering. C, secure coding practices. And D, conduct risk assessment. Can I just give every one of us a hint now? All these quizzes I'm giving you, please take note of them. If you can write them down, write them down. So I don't know, this might be useful for you at the class. So we'll take that as a very, 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 very wonderful freebie at this point. Okay, so we all got the answer. The answer is B. Fantastic. Thank you very much. This shows that we are indeed following. This is fantastic. Now, number 3, the CIA triad stands for A, connectivity, integrity, availability. B, confidentiality, information, authenticity. C, confidentiality, integrity, and authorization. D, confidentiality, integrity, availability. Let's go. I can see someone saying B. Oh, wonderful. Please let us look at the options carefully. Let us look at the options carefully, please. Let us look at the options carefully. Okay, I'm getting some B's and I'm getting some D's. Okay, so now the answer, if you look at your screen, that's the answer on the screen. The answer is D, confidentiality, integrity, and availability. Okay,